units are amperes. Now another important one is voltage. Another important one is voltage. So if you see the definition for this voltage, it is also known as a potential difference voltage. The energy required to move unit charge through an element is known as voltage, and it is measured in volts. Now let us see this definition clearly here. What is this energy required? Energy required or work done to move a charge through an element is known as a voltage. So let me explain these things clearly here. Let me stop this sharing. This I will share my canvas here. Please, is the whiteboard visible to you, Amma? Shravan, Sai Kumar.
Yes, sir.
Whiteboard కనిపిస్తుంది కదా. Now here I want to explain something here. We have already discussed about the charges. So there is a positive charge. If you take a positive charge plus Q here, plus Q, according to Coulomb's law, let us say there are two charges, Q1 and both are positive charges, Q1 and Q2. What is the force between them? Can anybody tell me? Which are separated by some small distance. According to Coulomb's law, the force is proportional to Q1 by Q2 by R square. Both the charges have the same polarities, positive polarities. Can you guess what is the type of the force between them? Please, anybody tell me? What is the type of the force between them? Is it the force of attraction or force of repulsion? Force of attraction. So there is a force. There is a force. This is known as this charge Q1 try to attract this Q2 due to this force F1. And if I move the same charge from here to here, again there is a force. Let us take this is a stationary charge, this is a movable charge. Again, if I move this charge in this particular version, there will be a force. If we keep on moving the same charge around the Q1, so there are forces F1 like this, F1, 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 where Q2 is movable charge. What I am trying to say is that if the Q1 is the charge which is at rest, position, so around the charge there are some force of lines. These lines are called flux lines. Which lines, Amma? Flux lines or force lines. Force lines are flux lines. Now, the region around this Q1 charge, as these force lines are due to this electric charge, these are called electric force lines. Now the region, this is a region around this charge. So there is some field, electric field. This field is known as a electric field. Try to understand this concept. Electric field. What this electric field consisting of? This electric field, the region around this Q1 is known as a electric field. As this charge is at rest, it is known as a static electric field. So what this electric field consisting of? There are some force lines. Force lines are exist. Okay. Now, as there is a force of what? As these two charges are of same charges, there is a force amount, repulsive force. There is a force of repulsion. Now, come to the point here. If I want move a charge at this particular point, let us say another charge Q3, which is also having the same positive charge. Now, what is the type of the force between this Q1 and Q3? There is a force of, again, repulsion. Force of repulsion. Now, if I want to move this charge at this, let us say this is position A to position B in the presence of electric field, in the presence of electric field, as there is an existence of force, repulsive force, then this Q3 need some external energy, This Q3 needs some external energy. So we have to expend some energy to move Q3 of charge in the presence of which field? Electrostatic field or static electric field. Okay. So if you are expending some energy, means you have to do some work. Work done to move a charge in the presence of, to move a charge from one place to another place, is known as a voltage. Is known as a what? Voltage. Okay. So which is denoted as a V. Are you following or not? Please respond. Sai Kumar, are you there?
Yes.
Okay. And see, I'll continue second hour also. Please inform to the students, because some of the students initially the strength is 24. Please pass the message in your unofficial group, because the students may think that you may join the second hour, but second hour may be also PWD. I will continue.
Okay, sir.
I will continue. Inform to your classmates. Sar is on leave. Today Sar is on leave. So I will continue second hour also. Are you following or not? What do you mean by voltage or current? Again, I will explain here. It is somewhat little bit confusion. Let me take another one also. See, what I am trying to say is that if you take a plus Q charge, there is a field. This field is known as a electrostatic field. It is in the form of force lines. The region around this positive charge, this is known as a electric field. Like suppose if you take a earth which is having a gravitational field, which field? And everybody know, gravitational field. If imagine it is an earth, if any objective is suspended above the earth, it is an objective, some matter, it is an object, some object above the earth, which is suspended above the earth. If you leave this object, then this object is trying to move in which direction? In the direction of the earth or opposite direction to the earth? Please respond. If any object suspended above the earth if you leave that object, it is attracted by the earth, is it? It is attracted by the earth. So what may be the reason here? Please, anybody can respond. What may be the reason? Why any object is attracted towards the earth? Suppose if you are standing on the third floor, if you leave any object, suppose if you leave a pen from third floor, if the pen is trying to move towards the earth, what is the reason? Hello? Ranjit?
Yes, sir.
Why the object is attracted by the earth? What may be the reason? There is a
Gravitational force.
simple question. Answer.
Gravitational force.
What is the reason? Shravan 103.
Yes, sir. Gravitational force, sir. Same answer.
Very good. Gravitational force ఉంటుందమ్మా. Gravitational force. Gravitational force due to the force, gravitational force. This object is attracted by the earth. Okay? Likewise, if you take a charge which is at rest means stationary position, according to the coulombs, around this charge there are some force lines. This field is known as a electrostatic field. Like a gravitational field, there is an electrostatic field if you take a charge. Now, my question is, as it is a positive charge, if you place positive charge here also, this is, let us say, Q1 and Q2, this is Q2. Yeah, what is the force between them? What is the type of the force between them? This Q1, there is a force of repulsion. What do you mean by force of repulsion here? This Q1, the charge Q1 plus Q, and this is also plus Q2, is trying to move Q2 in this direction due to this force, due to this electric force. Suppose if I want to move this Q2, let us say the location of this Q2 is A, and I want to move this Q2 the location B. So as there is a force of repulsion, to move this Q2 from A to B, we have to expend some energy. External energy to move this Q2 charge from here to here. If you expend some energy means we can say some work is taking place, or we can say work done. Work is done to move Q2 charge from A to B. Otherwise, I will give you an example. Now you are in the first floor. If you leave a pen from the first floor, the pen is attracted towards the earth. In this case, no need to do some work here because the earth is taking care of that pen due to the gravitational force. Suppose if you want to throw a pen from first floor to, let us say, a third floor. In this case, now you are standing on the first floor. If you leave the pen, it is compulsory move towards the earth. But if you want throw the pen to the third floor, you have to expend some energy. You have to expend some energy against the gravitational field. Against the gravitational field. Here also, the same situation is happening here. Against the electrostatic field, against the electrostatic field, if you want to move this Q2 charge from A to B, we have to expend some energy. You have to expend some energy, or if you have to expend some energy means work is done. Work is done. Finally, what I'm trying to say is that work done to move a charge. Work done to move a charge. Where this total situation is taking place in a particular conductor, copper conductor, all these situations are taking place because positive and negative charges are there in an atom. Okay, so there are some two electrons, there is a force of repulsion. If you want to move particular charge against the electric field, you have to expend some energy. The work done to move a charge against the electric field is known as a voltage. So I will come to the definition here. I will share the definition. Yeah. Now, if you read the definition of the voltage here, is the energy required? Just now you have seen why the energy is required. We are moving against the electric field. We are moving against the electric field. So we have to expend some energy. The energy required to move a charge or to move a unit charge means the value of the charge Q2 equal to 1 through an element. Element means here copper element is known as a voltage. So another name is potential difference. Okay. So now what is the voltage here? Work done to move a charge from one place to another place in the presence of the electric field through a conductor or element is known as a voltage. So it is measured in volts. The units, if you take any electrical quantity, compulsory there are some units, volts, and it is denoted by a letter V. Units are volts, it is denoted by a letter V. Okay. Now, another point is that related to voltage. Voltage VAB between 2 points A and B. Just now we have seen voltage VAB between 2 points A and B in an electric circuit. I will tell what is electric circuit later. Is the energy or work needed to move a unit charge from point A to point B is known as a voltage. Okay, and how to write this mathematically here? I already said that it is denoted with the letter called V, and between the terminals A and B, between the points A and B, work done is denoted as dW. You know, work done is dW. And charge, work done per charge, unit charge, work done per unit charge is called a voltage. Then how to write the mathematical expression? dW by dQ, work done per charge to move from A to B in the presence of electrostatic field is known as a voltage. The mathematical expression is dW by dQ. What is the dW? It is the work done. What is the dQ? Charge, where W is the energy in joules and Q is the charge in coulombs. And voltage VAB or simply V is measured in volts. So this is about the definition of voltage. Please. Somebody is asking.
Please allow them to join the class, sir.
Sure. Please inform them. no student is waiting here, please inform me to them. I'll give 2 minutes of time. So now any doubts for the definition of current and voltage? Any doubts for that? Karthik, 195, 18 batch. Akash, are you there, Amma? 104. Akash. Pranay, 19106.
Yes, sir.
Yeah, can you define what is the voltage? Anyone from the class? 105, 2105, Mehra. Please respond. Can you define the voltage? Just now we have discussed. What is your name? 105, 2105. మాట్లాడుతున్నారా మీ వాయిస్ వినిపించట్లేదమ్మా హలో 102 2102
Yes, sir.
yeah please, can you define voltage?
Work done to move a unit charge, sir, from one point to another point.
Okay, in the electrostatic field. Very good. What are the units for the voltage, Amma?
Units, 1 Newton meter per coulomb.
Units.
Meter coulomb, sir.
ఇది SI యూనిట్స్ కాదు, మీటర్ పర్ కూలు. ఇక్కడ ఆల్రెడీ ఓపెన్ చేసాము కదా. యూనిట్స్ ఏం చెప్పాను? SI యూనిట్స్ ఏంటి? ఇది CCS యూనిట్స్. SI యూనిట్స్
Measuring volts.
Please, the same define the current.
Current, sir. Time rate of flow of electrons, sir.
Very good. Or motion of electrons in a conductor is known as a current. Units, Amma?
Units, sir. I.
Denoted by I. Very good. Okay. Units like voltage volts kada atlane current units cheppanu.
Ampere, sir.
Very good. Amperes. And it is denoted by a letter, capital letter
Capital
A. Units represented by A and current represented by I. So these are the two basic definitions. Very
Yes,
good.
sir.
Some of the students following very good. Vaishnavina?
Yes, sir.
Very good.
Thank you,
And what
sir.
about the 05 and all those things? Please try to respond. I think that you are not in the class. If you won't respond, I'm thinking that you are not in the class. If you repeat 2 or 3 times, compulsory I will put an absent, because whenever I call you, I'm noting those numbers or names. Repeatedly, if you won't respond, I won't give the attendance. Okay, no? So, Meher, you are trying to saying something, but your voice is not audible to me. మిగతా వాళ్ళకి ఎవరికైనా వినిపిస్తున్నామా? 105 వాయిస్ నాకేమైనా ప్రాబ్లం ఉందా? Ranjit,
Yes, sir.
2106. Please define a current and voltage. ఇప్పుడే కదా తను చెప్పింది వైష్ణవి
Sir,
చెప్పింది.
voltage is measured in volts.
Very good. Okay. Definition amma. How to define a voltage? Because these definitions are very important. These are the
Voltage
basic
is a
definitions.
pressure from the electric circuit.
Definition చెప్పాను కదా వోల్టేజ్ అంటే.
Yes, sir.
మరి ఏం చేస్తున్నావు అమ్మ రంజిత్? వినట్లేదా క్లాస్?
వింటున్నా సార్.
స్క్రీన్ కనిపిస్తుందా నీకు?
ఎస్ సార్.
డెఫినేషన్ కనిపిస్తుందా?
ఎస్ సార్.
అట్లీస్ట్ చదువుతావా?
ఎస్ సార్.
చదవండి.
Voltage or potential difference is the energy required to move an unit charge through an element measured in the volts. Voltage
So,
between 2 points A and B is in a circuit. Electric circuit is the energy or work needed to move a unit charge from A to B mathematically. Yes, sir.
Mathematical. See Ranjit, be
Sure.
active.
Okay, sir.
Mathematically it is denoted as VAB equal to dW by dQ. Somewhat you are new to this terminology and all those things, but try to follow these classes. Once 2 or 3 classes are finished, then you may habituated to this terminology and you can follow. In the beginning classes you may face some problems and try to follow. So these are the basic definitions. The definition of the current is a flow of electrons in a conductor is known as a current, and it is denoted by a letter I. Units are amperes. Voltage is, and the mathematical expression for the current. Can anybody tell me the mathematical expression for the current? Current I equal to, like V equal to dW by dQ. dW by dQ. This is the mathematical expression. Likewise, what is the I? I already discussed this. What is the I? From anybody? Anybody from the class? Please.
dQ by
Listen.
dt.
Very good. Sri Varsha.
Yes, sir.
dQ by dt. So these are the, I will use these expressions later. So let us say this is equation 1 and equation 2. Current I equal to dQ by dt and voltage V equal to dW by dQ. Charge by time is current, work done by charge is voltage. So here there are some notations and polarities we have to follow for the voltage. Suppose if you take a battery, this is plus and minus. Longer line is positive polarity, shorter line is negative polarity. So it is a voltage, but it is a DC voltage, VDC antenna. So this is called voltage source, and this voltage having the polarities. One is plus polarity, another one is minus polarity. The plus and minus signs are used to define the reference direction or voltage polarities. While representing this voltage in a particular circuit, you have to use plus and minus sign. Okay. Now, point A is at potential of VAB, volts higher than the, see here, just now we discussed. There are 2 points called A and B. This is point A and this is point B. Plus is higher potential and minus is called lower potential. Okay. Now here, just now we have worked on to move a charge from one place to another place. So that we are moving a charge from A to B. To move a charge from A to B is known as a work done to move a charge. It's a voltage, right? So from A to B, we are moving a charge. So what is the point A here? Potential VAB is at a higher potential at B. Now, in a similar manner, the potential at A with respect to the point B is known as a VAB underground. There are 2 points, it is known as a, these are some basic things which are required to understand the KCL and KVL. You know, if you want to write this voltage, you can write VAB, this is plus and this is minus. Suppose VAB equal to like this. And if you want to write VBA, if you write polarities with respect to plus and minus, if you write VAB, because first subscript is positive, second subscript is negative. Suppose if you interchange these polarity, these subscripts like VBA, then compulsory that voltage will be a negative voltage. So a reference point, if the reference point it changes, that becomes negative. So that here you have to write minus. So what I'm trying to say is that, listen carefully here. In this figure, there are some examples. With respect to point A, with respect to point B, and if you write VAB, what is the VAB value here? Please, can anybody tell me? How many volts here? 9 volts. How many volts here? 9 volts. But see here. Suppose if you want to tell this voltage with respect to point B, VBA. Now can you guess what is the VBA voltage? If you take VAB, it is a plus 9 volts. If you take a VBA, what is the voltage here? Voltage will be 9 only, but the polarity will be minus. This thing, it is explained here. Okay, so there is a 9 volts drop from A to B are equivalent to 9 volts. Rise from B to A. But if you take a figure B, the point B is minus 9 volts above the point. So that is the difference. Whenever you interchange the vertical subscripts, then you have to give the negative polarity. Okay. Now let us see what is the power. Another definition here. Power is the time rate of expending or observing energy. What is this? Time rate of expending energy. Time rate means ETM. Time rate means DT. Energy is represented by work done or energy, W. So if you take a differential value, you have to take dW. Okay. So time rate of expending or observing energy is known as a power, and it is measured in watts. Our units are watts, W, and it is denoted by a letter P. Letter P. These are very, very important. Letter P. So current I, voltage V, power P. These are the electrical quantities. Now, how to write mathematically here? A mathematical expression can be written from the which one? Definition only. What is this definition here? Time rate of expending energy means dQ by dt. dQ by dt is power. Okay. So mathematical expression of the power equal to dW by dt. Time rate of expending or observing energy. So we have, just now we have seen about the voltage work done to move a charge. At the time we are observing some energy or expending some energy. If you take a particular time, the time rate of that energy is known as a power. These basic definitions are very, very important, and it is measured in watts. Now, from the voltage and current equations, just now we have seen the two equations. What is the current equation? I equal to, please respond on. I equal to, what is the first equation? dq by dt. What is the voltage equation? dw by, am I audible? Please respond on. What is the voltage equation? dw by
dq.
Very good, dq. Now, if you see the power equation here, P equal to, what is the P? dw by dt. Now here I am writing this, I am modifying this equation as dw by dq and dq by dt. What I am doing is that I am multiplying and dividing this equation with dq by dq. So then these two will get cancelled out. There is no change in the power equation. So if you multiply this dw by dt with dq and dq, and if rearrange these terms, dw by dq, dw by dq, and dq by dt, to rearrange these two terms. Now tell me, what is the dq by dt? What is the dq by dt?
I.
What is the dq by dt? Current I. What is the dw by dq? dw by dq is
Voltage.
so very good, very good. We can write the power is the multiplication of what? Voltage into current. See here. In this equation, same thing here is explained. P equal to dw by dt, which is equal to dw by dq and dq by dt, which is equal to voltage V and which is equal to current I. So V into I. Okay, the power, the actual formula is dw by dt, and if you want to write power in the form of voltage into current, V into I. So this is very, very important equation. So many times we use. This is equation number 3.